All right, so here we're on 10.6 on related rates. So with this problem, what we need to do is we need to think about what we have, and then we have to go from there. So it says we're going to do again, a 26-foot ladder is placed against a wall, as shown here in figure 1. Now, if the bottom of the ladder is moving away from the wall, so if we look over here on the ladder, it's moving away from the wall at 3 feet per second. What is the rate of the top moving down? So we want to know how fast is this going down when the top of the ladder is 24 feet above the ground. All right, so first things first, let's talk about the ladder and what it forms. Well, it forms a triangle. And so if we think about that, if we say that we have the equation x squared plus y squared equals the 26 squared, that would be our Pythagorean theorem, because we're just going to square this plus square that, and that's going to be equal to the hypotenuse squared. Now, the rate of x and y, the rate going out and the rate coming down, so the rate of y and the rate of x, they're not equal, but they are related. And hence, what we're talking about in this section is the related rates. Okay, so what we need to do is we need to take our equation we came up with, the x squared plus y squared equals 26, and we need to do some implicit differentiation with respect to time. Because if we think about this, x is changing with respect to time, it's going larger with respect to time. Y is getting smaller with respect to time. Now this one, 26, it's not changing with time, so that's going to be kind of the key here. So if we start with x squared plus y squared equals 26 squared, now we do it again, implicit differentiation. With respect to time. Well, again, the x's and the y's both had a time constraint or factor. So if we take that with respect to the time, that's going to give us 2x dx dt. Plus, this one's going to give us 2y dy dt. And the nice thing about a number, the derivative of that's going to be 0. Now we have related rates because we have the dx dt and a dy dt. Now, what do we know from the problem? The ladder is moving away from the wall at 3 feet per second. So that means dx dt is equal to 3 feet per second. What do we know y is? Well, the y, we said, is going to be 24 feet from the ground. So y is going to be equal to 24 feet. What do we know about dy dt? Well, that one we don't know. That's what we're looking for. And so if we plug everything in of what we have, we are looking for dy dt. We know y. We know that this is that. Now, what do we know about x? Well, we have to figure out x. So that's kind of what we need to do first, I guess. So x, we have to solve using this equation. So x squared plus, now y we said is going to be 24 squared, and that's going to be equal to 26 squared. So if we subtract 24 squared, x is going to be equal to the square root of 26 squared minus 24 squared. And 26 squared minus 24 squared is going to be 100. So the square root of 100 is going to be 10. Okay, and that's going to be feet. Okay, so now we've got everything except for our dy dt, and we can solve now for that. So we have 2 times 10, and then dx dt is the 3. And then we have plus 2 times y, which we said was 24, times dy dt, and that's equal to 0. So that's going to be 6 times 10, so that's going to be 60. So subtract 60, subtract 60. And so we get here what 48 dy dt equals negative 60. Divide by 48. And so dy dt is going to be what? Negative 1.25, and our units are going to be feet per second. So that's going to be the rate that the ladder is sliding down the wall. Now remember, this one was going out 3 feet per second. This one was going down 1.25 feet per second. So they're not equal as we stated over here, but they're related based on, we have that hypotenuse, so it has to be related on that. And so that is the solution to this problem that they're asking for. Okay, so let's stop there and we'll come back for more.